In this video, we're going to look at the Bohr model of the atom and do some examples. And we're also going to review atomic structure. So in the previous video, I went over the protons, neutrons, and electrons. The protons are large positive charged particles, and they are found in the nucleus. Neutrons are neutral particles, meaning no charge, also found in the nucleus. The electrons are negatively charged particles. They're found in energy levels or shells, and they're outside of the nucleus. And they're very light compared to the protons and neutrons. They are about 1/1800th the mass of a proton. So again, when we're talking about the mass of an atom, we can ignore the mass of the electrons. It's negligible compared to the mass of the protons and neutrons. Okay, there's some terms that you're going to need to know, and some of them sound similar and might be a little bit confusing. So the first one is atomic number. Atomic number just means the number of protons in an atom. In a neutral atom, so that means no charge. Another way to say that is it's not an ion. That means that the positive charges equal the negative charges, which means the protons equal the number of electrons. So you could say then that the atomic number is also equal to the number of electrons. Because the atomic number is the number of protons in an atom, it identifies the element. Every element has a unique atomic number. You can't change the number of protons. Well, you can, but if you change the number of protons, it would become a different element entirely. And the only way that would happen would be a nuclear reaction. Okay, mass number. Mass is the total number of protons and neutrons in an atom. You just add them up to get the mass number. So for example, chlorine is number 17 on the periodic table, and you should have your periodic table in front of you just so you can follow along. So that means chlorine always has 17 protons. That's what the atomic number means. Now the number of neutrons can change a little bit. We'll say that chlorine usually has 18 neutrons. And so if you added that up, you'd get a mass number of 35. Okay. Standard atomic notation, this is the way that you might see this written. So you put the element symbol, you put the atomic number in the bottom left, and you put the mass number at the top left. Okay, so this is the mass number. This is the atomic number. And this, we call this the elemental symbol. Okay, it is possible for chlorine to have 19 neutrons. If chlorine had 19 neutrons, well, this would still be 17 because it's still chlorine, but then this would become a 36. Okay, and so you'd call this one would be called chlorine 35. This one would be called chlorine 36. Those would both be called isotopes of chlorine, which is what I'll talk about in the next video.